Good evening, everyone. I would like all the participants to keep their microphones muted and their cameras on, if possible. And the session will begin shortly.
Large
Director, sir, shall we start?
I'm waiting for you to start.
Yes, sir. Okay, so good evening, everyone. I am Akshi Sharma, and a very warm welcome to all the distinguished guests, speakers, and participants joining us from across the country for the AICTE ATAL sponsored online faculty development program on next gen electronics and communication systems, empowered by ML and AI. Organized by the Department of Electronics and Communication Engineering, National Institute of Technology, Kurukshetra. To commence this inaugural function, I would like to invite our respected program coordinator, Dr. Pankaj Verma, to deliver the welcome address and set the tone for this week-long FDP. Over to you, sir.
Thank you, Akshi. Uh, on behalf of the Department of Electronics and Communication Engineering, National Institute of Technology, Kurukshetra, I extend a very warm welcome to all the present here for the AICT ATAL sponsored online faculty development program on next generation electronics and communication systems empowered by ML and AI. We are deeply honored to have among us our chief guest, the Honorable Director of NIT Kurukshetra, Professor B.V. Ramana Reddy, whose visionary leadership continues to guide this institution towards excellence in research, innovation, and academics. I also extend a very warm welcome to our patron, Professor Brahmjit Singh, Regional Coordinator, RACS ISRO, and our co-patron, Professor Karan Sharma, Head of the Department EC, all the deans, all the heads of the departments, faculty members, and the experts from the different organizations who have joined us this evening. The faculty development program spanning from 6th to 11th October 2025 is designed to explore the emerging convergence of artificial intelligence and machine learning with electronics and communication systems, a domain that is driving innovations in wireless communication, signal processing, VLSI, embedded system, healthcare, and even space applications. The objective of this FDP is to bridge the gap between the theoretical concepts and the practical implementations to enable faculty and researchers to integrate AI and ML techniques into teaching, research, and industrial applications. Through sessions delivered by eminent experts from IITs, NITs, triple IITs, ISRO, TCS, Qualcomm, and other reputed organizations, participants will gain exposure to the latest trends and tools in intelligent electronics and communication systems. We are delighted to share that this FDP has received an overwhelming response from across the country, A total of 455 participants from 403 institutions have been approved by our team for this program on the cutoff date, that is 3rd October 2025. Most attendees are educators, with assistant professors forming the largest group, along with the associate professors and professors, and then PG and PhD scholars. The participants come from the diverse fields including electronics and communication engineering, electrical engineering, computer science, and even from the civil background, representing different states and union territories, covering institutions from north to south and east to west, reflecting the national diversity and enthusiasm for interdisciplinary learning in the field of next generation electronics. This FDP also aligns perfectly with the AICT ATAL mission to upskill educators and foster innovation driven teaching methodologies. Over the next 6 days, the session will cover a wide range of topics such as machine learning in wireless communication, AI in healthcare, VLSI, industrial, and space applications. The FDP will conclude with an online assessment, feedback, and valedictory session on the 11th of October 2025. Before we proceed further, I once again welcome our Honorable Director, our distinguished guest, all the faculty members of NIT Kurukshetra, our participants from across India to this online FDP. I hope this week-long program will serve as an enriching academic experience, promoting collaborative learning and inspiring new ideas for teaching, research, and innovation in the field of electronics and communication engineering. Thank you and welcome once again to this ATAL FDP. Thank you.
Thank you very much, sir, for the warm welcome and for giving us an insightful overview of this FTP. And now I would like to invite our co-patron, Professor Karan Sharma, head of the Department of Electronics and Communication Engineering, to address the gathering and share his words of encouragement.
Well, good evening, all the members of this team who have planned out this 6 days FDP program. Greetings to you, sir, our worthy director, sir, Professor Reddy. He's also with us. I'm so happy to see him here. A very good evening and greetings to Dr. Brahmajit Singh, our regional coordinator of the ISRO program here. Well, I am here as head of the Department of Electronics and Communication Engineering. From the core of my heart, I welcome all the members who have found time to join this program. Well, we have, as Dr. Pankaj said, an overwhelming response to this program. Yes, it had to be, because this is the title is so catchy. Next generation electronics and communication systems empowered by machine learning and AI. So I heartily congratulate our coordinators of the program, Dr. Pankaj Verma and Dr. Trilokinath Sasamil, along with Dr. Mohit Dua from the Computers Engineering Department. Am I audible?
Yes, sir, you are audible.
Okay. So at the very outset, let me just give you an overview of my department here. In the last couple of years, we have had a lot of shuffling, planning, and curriculum revision. So presently here in the department, we have three full-fledged BTech programs. The earlier program, it was Electronics and Communication Engineering program. But now we have added on to the latest cutting edge technology-based program, that is BTech in IIoT. It is industrial IoT, we call it. And then we have the third BTech program. This relates to microelectronics and VLSI design. And then we have three MTech programs, one in communication systems, one in VLSI design, and one is in the embedded systems. And then we have a number of research areas where our PhD scholars are undertaking interdisciplinary research. The latest areas of electronics, communications, and intelligent systems. So, well, this program, as Dr. Pankaj, he had been sharing in the introduction, that this is basically to give you an insight into the modern techniques of integrating AI and ML into our mainstream modern electronics, communication systems, and intelligent systems. So I welcome everyone here, and this kind of a design of the whole program. Well, this is going to be giving you a new insights into designing your curriculums, especially for the faculty members in your own individual departments of your institutes, as well as it will give you a new insight into the new teaching methodologies, because now AI and ML, this has proliferated into almost all the domains, all the dimensions of engineering applications. So be it electronics, be it electrical, be it mechanical engineering, in general, we are these days more focused on data analytics, data science, whereby the data and the material is provided. And then AI and ML, this helps us to take insightful decisions, which are better, which are faster. Just today only, I was sharing with one of my old pass outs from the department, and he has been here today to recruit our new BTech graduates. So he was talking in detail about the advent of the latest in AI and ML. And what he was saying was that he is conducting the interviews, but then he need not be really working upon the selection process. Everything is provided to him by the ChatGPT program and the other platforms, and he has to be just putting in the summary of all the students, and then he gets the final results at a faster note. So, well, this is what, and in the coming time, he said, we will not be needing coders. And till date, we had been having promising coders from our engineering streams who were seeking employment. But then he said, now we don't need coders. Everything is done through the machine learning platforms. So that's how the whole landscape is going to change. We are now working into the evolving landscape, the modern techniques in the industry, the requirements of the industry. Well, we have four major areas. One is data science, one is IoT, AI, and one is VLSI, where as professionals, we have to be giving in our insights. So all these areas, they are all interrelated. And IoT and AI, they happen to be on the highest lists of corporate priorities these days. And the corporate industries, for their faster operations, for reducing their manpower, and for achieving minimum downtime, they are employing AI in a major way. So we are going to be seeing across in the another times to come, in another 2-3 years time, the whole scenario is going to change. A lot of people are going to be losing their jobs as the trends have just started, because there'll be lesser and lesser dependence of physical human minds and physical heads. So we are now making the computers learn, and then they take our decisions for all the processes. Now, for the time to come, for the next 6 days, I wish, and I have seen a whole list of experts and the kind of topics where they'll be dealing. So it's not only the theoretical knowledge, it's going to be also the practical skills that you are going to be picking up. So continuous learning and skill enhancement. Uh, this has to go hand in hand. Without this, we'll be lacking. So we are here to provide you with the abundance of topics in AI, especially in the areas of wireless technologies, industrial applications, space applications, embedded system, again, machine learning in wireless communication, AI in healthcare. Well, I have practically seen how this AI in healthcare can be providing you information in seconds. So the last few months' time, my father had been hospitalized, and even the doctors, they were not very sure how to proceed with the treatment cycle.
Your mic has gone mute by mistake.
So please unmute yourself.
Yeah, it's there now.
Yeah, sir, it's fine now.
Okay, I don't know since when I mean you could not hear me. Okay. Shalom. I was just sharing with you about the latest topics and the kind of amalgamation of theoretical knowledge as well as practical insights that you are going to be picking up. You are going to be put to a number of case studies where the latest state of the art tools will be available to you, whereby you can express yourself and our experts will guide you to it. So, on the behalf of my department, all my colleagues, I extend my sincere warm welcome to all of you. And I wish you all have a very happy and exhilarating learning experience during this program. So, thank you all very much for inviting me onto your platform. Now, I extend to Dr. Pankaj.
Thank you, sir. Akshi, please continue.
Yes. So thank you, sir, for your motivating words and for your constant guidance and support. And before we move forward, I would like all the participants to keep their mics mute and their cameras on for better flow of the event. And now, I think it's my honor to invite our patron, Professor Brahmjeet Singh, Regional Coordinator, RAC's ISRO, to address the participants and share his thoughts on his theme of this FDP. Over to you, sir.
Thank you. I am audible.
Yes, sir,
Sir,
you
you
are audible.
Audible, sir. Respected Professor B.V. Ramanna Reddy ji, Honorable Director NIT Kurukshetra, Head of the EC Department, Dr. Karan Sharma ji, faculty members, resource persons, organizing team, Dr. Pankaj Verma, Dr. T.N. Sasamal, Dr. Mohit, and dear participants in this ATAL FDP on next Gen Electronics and Communication Systems empowered by machine learning and AI. Namaskar to all of you. At the outset, my sincere thanks to the organizing team for inviting me to be a part of this inaugural function of the FDP. Next generation electronics. Electronics or nowadays the buzzword is semiconductor. Semiconductor has become an integral part of our personal life, professional life, business, governance, all walks of life, all spheres of life. All the systems we used in our life, they are using semiconductors. Our life is indeed filled with electronics. Even the chips are being implanted in human bodies. So electronics is not merely in the systems or networks, it is coming to our human body as well. And this shows the importance of electronics. Coming to the next generation electronics, which is of course is the theme and topic of this FDP, we know that next generation people, they like speed. They want to drive at high speed. They want to use the internet at very high speed. They want to rise in their career at high speed. Now the question is how to meet this demand of this next generation. Here comes the electronics. Next generation electronics has to be faster, it has to be efficient, and it has to be more innovative. Probably nanomaterials, graphene, flexible electronics, something like that will make the next generation electronics which will match the demands of the future generation. Coming to the next generation communication systems, particularly telecommunication systems. Here also user wants speed. As we know, there are three components in any telecom networks: transmitter, receiver, and channel. Very sophisticated and innovative design of transmitter and receiver has happened. Now the target is channel, specifically wireless channel. Despite channel being very hostile and unpredictable, the question is how can we enhance the performance of these systems? I think here comes the role of artificial intelligence and machine learning. It is for sure, it is the intersection of AI, ML and next generation of telecom, which we perceive as 5G and 6G. And that is going to shape the future of communication systems. And the days are not far away when we will have semantic communication as well. Native AI ML would allow radios to adapt while on the move, while on the fly to changing environments, and they can change their transmission conditions as well. This adaptation is being empowered by machine learning and artificial intelligence. And we hope that it will make the 6G networks highly efficient in terms of data rate, energy consumption, and response time. I do believe these issues will be discussed and insights will be drawn over the time during this 5 to 6 day FDP. Contents are really very well designed and thoughtful. A big thank you to the organizing team. I'm looking forward here. So many participants have joined. So big congratulations to the organizing team that you have been able to draw the participants from across different parts. And a big number, 455 given by Pankaj, and probably around 160 are online. So congratulations to the organizing team. At last, I wish all the participants happy learning. Jai Hind.
Thank you so much, sir, for your inspiring and visionary address. It is now my privilege to introduce our chief guest, the Honorable Director of National Institute of Technology, Kurukshetra. Sir is a distinguished academician, visionary leader, and a guiding force behind many initiatives that strengthen research, innovation, and institutional growth at NIT Kurukshetra. Under his able leadership, the Institute continues to scale new heights in academics, research, and outreach. Professor B.V. Ramana Reddy took over as Director of National Institute of Technology, Kurukshetra on 5th February 2022. He is an alumnus of Andhra University, IIT Roorkee, and NIT Kurukshetra. In his long career spanning over 35 years, he served in various capacities as teaching faculty at national institutes of repute, including NIT Kurukshetra during 1991 to 95 and NIT Hamirpur from 1995 to 1999, also known as REC earlier. He also served as associate professor and as professor at University School of Information and Communication Technology, USICT, GGSIP University, New Delhi for the last 22 years. He possesses an excellent academic track record both as teacher and as a researcher, besides administrative acumen in technology areas of information and communication technology. Been in service for the last 35 years. Earlier, he served in various positions as Dean School of Engineering and Technology, Dean of University School of Information and Communication Technology, Dean University School of Architecture of Planning, and he was also the chairman and centralized career guidance and placement cell of GGSIP University and program coordinator of GGSIPU, NSS cell and NCC cell, having 15,000 NSS volunteers and 500 NCC cadets at GGSIP University. He has more than 100 publications in international and national journals and international conferences of his credit. We are truly honored to have you with us today, sir. Now, I request you to kindly deliver your inaugural address and formally inaugurate this faculty development program. Over to you, sir.
Good evening, one and all. I think I'm audible.
Good evening, sir.
Yes, sir, you are audible.
Okay.
Yes, sir.
So I really warmly welcome all the participants spanning across the country for this online 6-day faculty development program on next generation electronics and communication systems empowered by machine learning. So let me warmly welcome my colleagues, Professor Karan Sharma, who is heading the Department of ECE, and Professor Ramjit Singh, who is a colleague, and we have a journey together since the last 30 years, and a faculty of ECE Department of NIT Kurukshetra. Along with, we have the organizers, Dr. T.N. Sasamal, Dr. Pankaj Verma, and Dr. Mohit Dua, who are the program coordinators for this conceived program of ATAL AACT ATAL FDP program. Now, it's a wonderful concept and a wonderful conception, the way it has been conceived. Looking forward to the futuristic techniques and technologies which engulfs the Department of Electronics and Communication as one feather in the helm of affairs. Because these days, the topic is so relevant, so important, and so interesting that every field of engineering, non-engineering, is looking forward to these AML tools for furthering knowledge in the respective areas, for finding innovative and new techniques and new technologies, which to my mind will be disruptive in nature. We have a wonderful journey over the last 50 years of expansion of these departments of electronics and communications. And we now call them as departments of ICTs, Information and Communication Technologies. Now, the departments of Computer Science, IT, the departments of ECE, Communications, cannot live or sustain without the understanding about the tools that are available today. And if we are not holding these tools into our research problems or into our new techniques and technologies will be laggards and will be nowhere in the system. I was happy to note that more than 400 have enrolled for this FDP program. I really appreciate all the young faculty who are enrolling into this program and will be working for the next 6 days, albeit on an online platform, and that too in the evenings from 6 to 8 p.m. Now, really, it is heartwarming and a wonderful effort from NIT Kurukshetra. I appreciate the department for having conceived this, and led by Professor Karan Sharma and Professor Ramjit, along with the young faculty. I really bless you all with this effort. And as I said, and I was also happy to note that other engineering faculty coming from civil engineering, mechanical, electrical, and I mean, there's no limit to this understanding of these tools, which are going to help. So, in this direction, NIT Kurukshetra has made one of the papers, AI and ML, to be a compulsory paper across the board in all our 15 engineering disciplines. So that shows the importance that is attached to this subject, and how deep it is going to go, and then change the way we do our research, also the way we understand these techniques and technologies. Having served the Department of ICT for over a long period, along with EC department, I'm really very happy to have learned um, the few beginnings that we started with, the basics of electronics, to understanding this use of semiconductors in a big way, the way we are engulfing the whole world with the techniques and technologies, leading to wonderful areas. And the fusion areas are coming from this hardware and software areas. They started in two formats, one leading to what we call as the VLSI areas, very large scale integration, and use of algorithms to embed softwares into hardware. And the second very interesting area, which has a fusion of the communication world with the world of computing, thereby whatever we are enjoying today on these online platforms, as one of the examples, we are able to integrate voice, video, data together, and are able to reach out to billions of people across the world through and then I should not say thanks to the period that we saw, which ensured that this disruptive technologies of online education has come in during corona period, where we did really understand the importance of this these technologies, which we have perfected, and the way we are learning things now. So I think there's a great deal of research to be done. There are so many exciting areas of working, where we are now progressing towards looking at what can be the possible guidelines for us. How do I use these AI ML tools to enhance my understanding in the areas of electronics, in the areas of communications, leading to the new disciplines that we have already started, as already said by Dr. Karan Sharma. Apart from the two engineering disciplines, BTech programs we have started, we have also started programs related to mechanical. We now have robotics and artificial intelligence as one of the BTech papers offered by the mechanical department. We understand the importance of data science and AI/ML. So we have started two BTech programs under computer science and engineering. A third BTech program we have started in mathematics and computing. So you can see the range of subjects that are coming your way, including a bachelor's program in VLSI and IIoT. To your knowledge, let me also bring to you, we have started another BTech program in sustainable technologies. I think tomorrow's world or today's world will not allow the researchers to find novel solutions until unless they are sustainable. So we at NIT Kurukshetra, we take these two buzzwords very, very seriously. How do we impart sustainable technologies to you, and see to it that every engineering field owns this kind of a branding, that whatever I do my research, whatever tools I'm going to develop, whatever tools I'm going to use to enhance the future research activities, they all should be sustainable in nature. So my advice to all of you is, I wish you should learn these tools of AML, and in what way these machine learning tools are going to help you in progressing in your own research areas or teaching your subjects. But then a small two examples I'll give you to make it much more interesting for you. Initial days when the mankind was progressing, the basic requirements we look forward to is food, shelter, clothing, and these were the basic requirements. Roti, kapda, makan, we call them. And all the energies were focused on to develop these areas of engineering, what we call today, to ensure that we give you wonderful housing solutions, wonderful social living conditions for you. And then we perfected the art on these things. Then beyond this, come 80s and 90s, we started looking forward to how do I communicate with each other? How do I ensure that I can have a worldwide networking, a worldwide communication links formatted, and then I should be able to talk to each other. And this led to the definition of the basics of communication. Today we talk about wireless communications, from wired to wireless, and we have perfected the art of going deeper into it, into areas of what we now call them as Internet of Things, and how Internet of Things is engulfing the whole world with its wonderful applications, sans every area of living. So the beauty of this particular thing happened, as I said, is a fusion of communications with computing, wherein the very first intelligent devices started being built up. How do I create intelligence into a given system? I'll give you by another example that whatever we are learning today, we are all learning and mimicking the human body and the human mind. So that becomes my reference point as to any new developments that I'm going to look forward to. I'll be looking forward to with a lot of awe and enthusiasm as to how this biological body works. And I can give you examples with the human body itself as to how we have evolved into these areas. So if you look at the human body, I can visualize it to be a complete hardware of certain elements and interconnections with these elements, and I'll be able to utilize the functions of a centralized unit called your brain to ensure that all the functionalities that we do as a human being are coordinated, well organized, and I'm able to interact with other biological bodies also. I think that's the cue from where we started learning our basics, trying to understand through electronics what could be the hardware that is required to build such a device or a circuit or a system. So having learned this art, the next step that I wanted to learn through is how this hardware is interconnected. And this basic example that we always learn through our basic computer, where we talk about a central processing unit, a memory, and then we talk about various IO devices. Similarly, the human being also has all these in its armory. Now, if you look at how this functions, is like we say, computer functions with the hardware that it has, along with it, a hardware without working models, without working programs, it doesn't function. So, a human body also has a brain, a memory, and certain algorithms that are embedded. We call them as system level algorithms and application level algorithms. The system level algorithms take care of the functions of the body 24/7, 365 days till we die. So it takes care of all the functionalities, checks with its instruments, checks with the connections, checks with the availability of these resources. It creates a battery bank, it creates a memory bank, and then we have a process of learning in a human mind. Can I mimic these activities which I have done through the human body? Do I have application programs? Yes. Mothers teach us so many things. We learn through those algorithms and we embed it into your memory system. And then comes a comparison of one element with the other element. And we have those algorithms already embedded into us, which tries to give you information as to what to be processed, how it has to be processed, how this rotor motor activities will take place. Is a new area of robotics. Automation is the key. So a human body is mimicking your robotic arms and robotic movements and robotic activities. And then we have entered into an area. Now everybody asks me, application softwares is fine, system softwares is fine. What about virus, and what are the solutions that you give to the human body? Antivirus. We very strongly believe in NIT Kurukshetra that virus can be tackled. Antivirus has to be given in the forms of values. We call them as human values. So if I can understand these value systems, probably I'll be the best human entity in the society. So as I said, we take two things very seriously in our education system at NIT. One is, how do we develop holistic personalities by giving them proper algorithms, proper antivirus in the form of values and systems, so that he becomes a useful entity to the society. And the second important aspect, as we try learn, is an area of IoT. All your five senses, or your five elements through which you see the world, are nothing but the elements of an IoT system. So it also functions the same way. It is, you see the autonomous car, what does it have? It has got the sensory items in its armory, which will allow it to see visual impacts. It can see, it can listen, it can maneuver itself in such a way wonderfully. It's again, IoT is nothing but interconnection of all these sensory organs which we have, and passing on this information to the brain, which collects all this information and processes it and takes its decisions perfectly very well. It can be rotary motory activities, it can be anything through our nervous system. All our communication network is our nervous system, which ensures that all these activities are perfected and we are able to take it forward. Now, having said this, what is that I have to mimic in the human body for the next generation of electronics and communications? As I said, it's a wonderful fusion of what we call as algorithms or routines. So what can a robot do? A set of routines. These set of routines earlier used to be prefixed, and it cannot function beyond the pre-prescribed algorithmic movements. Now, what are we doing today now? What is that we want to make it? We want to make our devices more smarter. We want to make them more intelligent, and we want them to take their own decisions as a human body does, or a human mind does. How do we go for it? The best way to go for it is start learning how a human mind works. Intelligence. How is this intelligence created? How this intelligence is packed or memorized into the neurological systems in the brain. How does it, this comes out again and then works, compares, and takes a wonderful decision beyond? Now, can we do something on this? And researchers have done wonderful things in this direction, and they created what is called as artificial intelligence models, wherein we try to learn from a parent-child model and then try certain algorithms so that we will be able to understand the repetitive actions, and can these repetitive actions be simulated through a robotic models, or give this intelligence to the respective devices. So then these offshoots of this artificial intelligence and their algorithms are the one which we are now learning and trying to understand the implications of these, and how I can embed these things into my devices, my circuits, my systems, so that they become autonomous in every aspect, not only to function with a pre-prescribed routines, but to learn through its own experiences. So here comes your machine learning and deep learning algorithms, which functionally tries to understand these things and makes the device more intelligent, more understandable, and then ensure that this understanding that it acquires, can this be data, which a huge data we collect, can this data be siphoned through, simulated through, understood, and then make decisions on its own. So this is where our electronics and communications is entering. There is no space where we only talk about devices. We can talk about intelligence to be added to networking switches, to the networking routes, and to ensure that optimal utilization of these resources can be done by dynamically finding ways and means of effectively utilizing these things. So since you'll be starting with the basic definitions of machine learning, so we need to understand what is this machine learning. Machine learning is a branch of artificial intelligence where algorithms enable computers to learn from data and identify patterns without being explicitly programmed for every task. So that makes it some kind of learning models are to be given to this, and naturally I need to learn those languages which will help me, Python and others, to help me out. How do I write these programs so that the machine will become intelligent in itself and try ways and means of performing tasks like recognizing, prediction, fault detection, futuristic, what can go wrong and what can go right, taking care of images and image recognitions also. This is just a small list which I'm trying to give you. This can be extrapolated to any kind of applications, wherein I think there are so many hazardous areas like chemical industries or others where human intervention has to be minimized, and we automate these things in such a way that these devices can control very complex processes that can happen in an industry or otherwise, like automation of your agriculture, taking care of your bodies and health conditions, to anything you name it, it's going to happen. So I call it roti kapada makan, communications, and then now AI. So this is the way that we're going to look forward to, and then see how we can do. But what is the key for this machine learning processes? What are the important elements that one should keep an eye on? This is the data is the key. So voluminous data is available to you. How go through sift through these data elements? How do you do a deep algorithm into onto it, or machine learning algorithms onto it? So these techniques will help to create a self-aware, self-recognizing, self-programming, and connecting to the future. Which a small example, you can hire a person who is a watchman, and if you give an instruction to the watchman, keep watching. Now, following day, everything was looted because the algorithm said, just watch. So the machine cannot go beyond watching because that is what algorithm you have taught to it. So then you have to again tell some other elements. So when you go through these processes, there is something which is still missing in this process. So you need to make the machine learn on its own. Even the human being learns through his or her mistakes and then perfects the art of doing so. Then the second important aspect is pattern recognitions. What are the ways by which we understand a process that is happening? What are the patterns that are happening? Now, if I want to find a thief, there are certain patterns. Is a good person or a bad person? These patterns have to be evaluated, and you come to a conclusion that by these traits, he must be a thief. By this, I can say he's a dacoit. By these traits, he can be something else. So this pattern recognition becomes very, very important, and learning through these machine algorithms is important. So this learning and improvisation becomes a very important component of these machine learning models. Finally, you have to make decisions. It's not just learning the process, but you have to make decisions out of it. So that predictions and decision making also is a part of this machine learning and embedded systems. So what is that you're looking at these tools to be helping you in your own departments or in your areas of research is it's an autonomous learning models. So how do I make it more and more self-learning models? Like a child needs a lot of inputs at a school level. By the time he comes to 15, 16 years, he's embedded with certain machine learning tools or the ways he can learn new things. And that helps him finding his own ways of understanding. There's no teacher, there's not nobody around him, but his own experiences make him learn more. And that is how you're going to make it an autonomous learning model. And the second important component is adaptability. You have to adapt to that situation every time. Like an autonomous car, it encounters different situations and you have to be adaptable to it. Like Sasamal is a wonderful driver and a rash driver. Now this machine also starts learning the same way and tries to mimic this person called Sasamal, whereas the autonomous learning was wonderfully good. But because of this human brain in its learning, now it becomes very tricky for this machine to learn how fast it has to check with it, because now that adaptability with that situation is very important. Otherwise, whatever it has learned, this can be a difficult situation for it. So AIML tools are at your side, but you have to be much more intelligent to write such programs and help it to learn faster than what you can think and faster than what you can do. Now, what are the application areas if you look forward to? Recommendations systems, image speech recognitions, fraud detections, NLP, and the list is very, very far and deep. You cannot just say that this is what is an important thing which I'm going to tell, and this is the end of it. This is the start of the story, and this story is to be very big. It will engulf every area, and the future students of ours need wonderful teachers like you who are willing to learn, who are willing to create that kind of learning environment for my child to ensure that these models help you in your teaching also, help you in your research and research techniques, methodologies also, and also will help the youngsters to think differently, be more creative and innovative in their application world, and they will bring laurels to the country and to the world in this area. Now, if you look at, as I said, this is a fusion area. So there are many things that as a teacher you have to learn if you really want to be in the trade of teaching, because teachers need a lot of these learning models to be adopted, and very, very important for you to keep an eye on the new techniques and new technologies that are coming up. Now is the time. It is a non-linear evolution. It's not no longer linear. Every day there is new knowledge that is adding up to us, and we as teachers, we have onerous responsibility to own this knowledge, adapt to the new techniques, work with new research areas, and ensure that new products will come into the market and makes lives more easier than what we think of. And a word of caution, as I said, a lot of problems we have created to Mother Earth. Now is the time that you need to look forward to sustainable solutions. Technology per se is not bad. Technology, how it is being used, is of paramount importance, and we have to learn the art of doing this kind of things. Like if you look at electronics, what can I do? Smart circuit design can be one big area where I can think about it. Fault detections, where you are very much interested in to understand this. Power optimization. Many of us have done research wherein we have to find novel ways of reducing the power consumption, and also how do we reduce the power utilization while we undergo levels of VLSI models that we learn through. And then we are talking about now AI chips as one of the areas, and neuromorphic hardware that mimics the human brain. I've always given you that example. Now it is the time that you have to work towards that and find ways and means. Now in communications, how these ML techniques are going to help you. Signal processing, I already referred to. channel estimations, because now the networking is done. What we are looking forward to is by 5 billion entities to be connected. So if you need a connection of this huge mammoth, naturally the networking that we have, both wired and wireless, have to be optimized, have to be done. So many machine learning methods can be applied across them for what we call as channel estimation, modulation recognition methods, spectrum management, so on and so forth, and to create more efficient, reliable networks. So we are now talking about 6G and beyond, and we are also talking about IoT ecosystems. I think without these tools, I think future research becomes a roadblock, and it is necessary for us to learn these things. Now, no area is, as I said, you are students of, or sorry, faculty of ECE, but then tomorrow's world, you'll be going to help mechanical, civil, electrical, electronics, everybody in this engineering field into using this particular knowledge to enhance better communications, better devices, looking forward to futuristic techniques and technologies. Now, you can take the examples of autonomous vehicles, robotics, and how AI and ML is going to revolutionize the way we commute, the way we are going to do. Maybe we'll be going for flying cars and flying motorcycles very soon. And all your drones are going to deliver, um, replacing all your delivery systems. Um, Probably that's the day you're going to see very fast. Smart healthcare is going to be the new norm. Industrial automation, I refer to it, and then smart cities. And then we talk about AI native communication networks, which can learn, adapt, and optimize themselves through an intelligent and connected world. So, likewise, you can discuss. I think these 6 days you have a lot of speakers who are going to enthrall you with the knowledge which they have gained in their specific areas, be it how machine learning is going to help in wireless communications, the role of AI in satellite communications, talking about AI in healthcare. You have data driven haptic modeling and rendering by another expert. We have, as I said, spectrum sensing is very big area where we need to effectively utilize the communication channels. More so in electronics, how do we use this? Because we are going to have ultra low power requirements, ultra low size of devices and chips. So naturally, a lot of work has to be done in that area. So even these transceivers, RF transceivers, are going to be transformed into wonderful entities. I think the world is beautiful, and I see a bright future for my youngsters and my world. As I keep saying, um, technology is like an elephant. You should know how to ride it. Allow the technology to sit over you, then this elephant will crush you. So be intelligent enough, give wonderful solutions to the world. We have done a lot of damage to the interpersonal relationships and others. Though we say we are connected, everyone, I think we need to revisit our technologies to find such solutions which will help the future generations to smartly utilize the technologies, not the way that is being done today. We need to connect people. We need to look forward to beyond. There are so many such things, like we have conquered the vision, we have conquered the speech and listening. What about sense of touch? What of the emotions? How do we communicate these emotions from one part to the other part? So there are many things that we need to come forward to. Can we have systems embedded into our bodies? Yes, we have human machine interfacing that's being happening. Maybe tomorrow this science will go beyond, and probably we'll do away with devices, and maybe human beings talk to each other much more effectively. I think that day is not far where we'll go up to that research as to how one human being can connect to another human being without having any gadget. I look forward to such a wonderful societies wherein you can connect to the whole universe and start loving each other. Love you all. Thank you for giving me this opportunity. I wish the organizers and the wonderful FDP participants across the country, I wish you have wonderful learning platforms through these sessions, and we'll have exposure through wonderful speakers, both from industry and from academic world. Wish you all good luck. Love you all. Thank you for giving me this opportunity. Jai Hind, Jai Bharat.
Thank you, sir.
Thank you, sir.
Thank you very much, sir, for your inspiring and thought provoking address. Your
And
words have truly
I forgot
motivated
to
us.
say, I declared this FDP open, and I will be interested in coming back to your last session where you're going to wrap up what has been learned. I would love to listen to the participants and see what is their learning in this process. So I wish this FDP marks a wonderful new beginning for all the learners. Many of them have got vaguely good ideas about AIML, I'm pretty sure, but then you have to have deep knowledge. I encourage all of you to learn more and then use this knowledge for the benefit of mankind. Thank you.
Thank you, sir. Thank you.
Thank you very much, sir, for your inspiring and thought provoking address. Your words have truly motivated us to explore the frontiers of AI and ML in the field of electronics and communication. Now, to conclude this inaugural session, I would like to invite Dr. Trilokinath Sasamal to propose the vote of thanks. Over to you, sir.
Thank you. Good evening, everyone. It's a both honor and privilege for me to propose the vote of thanks on this occasion of our FDP. First and foremost, I would like to express my gratitude to all the honorable guests for gracing us with their benign presence today. A special thanks to our chief guest, Honorable Director NIT Kurukshetra, Professor B.B. Ramana Reddy, for kindly accepting our invitation and for graciously inaugurating this program. On behalf of the organizing committee, I convey our deepest regards and sincere thanks to him for sparing his valuable time and for his unwavering support and guidance, which has been a constant source of motivation for us. I'm deeply grateful to Dean Faculty Welfare and Dean RNC for their unconditional support. I would like to extend my sincere thanks to administration of NIT Kurukshetra, CCN, the account sections for providing all possible logistic support that was crucial in organizing this event. On behalf of the organizing committee, I sincerely thank the ATAL Academy for sponsoring this FDP at NIT Kurukshetra. Their support and initiative have been instrumental in fostering academic excellence and encouraging research innovation. My thanks also go to all the participants for their involvement. We have been fortunate to have eminent resource persons from both academia and industry, and I have confidence that all the participants will greatly benefit from the insight gained during this program. Once again, I extend my sincere thanks to everyone who has contributed directly or indirectly to the smooth and successful conduction of today's event. Thank you all.
Thank you sir, for your heartfelt words of gratitude. Now, I would like all the participants, speakers, and everyone else to switch on their cameras for a group photograph. Can you all please wait for a few seconds?
Thank you, everyone.
With this, we formally conclude the inaugural session of our AICTE sponsored FDP. We once again thank you all the dignitaries, speakers, and participants for gracing this occasion with their presence. The technical session will begin as per schedule on the same link. Thank you and have a wonderful evening ahead.